Okay. So we're recording now, so just so you know, if there's anything that you don't want recorded, maybe put it in the chat or follow up with an email afterwards. So like I said, this is going to be useful. I think in a typical year, 90% of the projects would benefit from using American Community Survey data because it gives you a really quick picture of the community that you're interested in or that you're working on at a very spatially granular level. But here's some of the reason why I'm talking about the census and ACS data together and how they're related. So basically the decennial census, and this is probably on your mind now because this is a decennial census year, serves as constitutional mandate to basically enumerate the populations by state. And the purpose of that is reapportionment in the House of Representatives, right? So representatives. So it has a very specific purpose. And then based on that, we draw very different boundaries. And to do the boundaries for reapportionment, you need data at the census block level. And I'll go into the hierarchy of census geographies later. But basically, a census block level is a very, very small grouping of people. So it's very geographically granular. In the 1820s, they also started to collect additional information with the census. So they didn't just count you, right? But they also asked you a bunch of questions to also better understand the population. And so this form of the census was called the long form. But because this long form was really intense, right? So if you think about a respondent burden, if I ask you 50 questions, you need to dedicate some time to that versus now when you fill out the form online, you maybe answer 3 questions and you're done. Because of that, they decided to reshape the census long form into 2 different things. One is the census, which basically enumerates the population and collects some really basic sociodemographics. And here I'm showing you kind of the timeline so that you know when you're working with the data, at what time point you can get particular data points from the census versus the ACS. So that most of the long form got broken out into what we now call ACS. So these particular numbers here, you know, if you're not working on a project that's going back in time, might not be relevant to you, but if you're trying to track, you know, gender composition or percent population that lives in poverty, you might have to switch back and forth between census and ACS depending on the time period that you're observing. But basically, in this last, you know, couple of decades, you should be getting most, if not everything, from ACS. So the questions that are now in ACS that used to be in long form before span everything from ancestry, so, but that in terms of, you know, foreign-born, population educational attainment, income measured several different ways, language proficiency, migration between states, between counties, outside of the US, various types of disability, employment characteristics, and then also property or housing characteristics. So there's quite a span of data that you can get there. The data set, like I said before, it's used by public, private, and nonprofit sectors. So if you end up in a polling research organization, in a think tank, you know, Brookings Institution, I don't know, any of these, they'll rely heavily on ACS, right? The data is publicly available. It's very easy to work with. So it's the basis of a lot of things that you see out there. You know, the flashy, glossy, nice reports that come out of these think tanks, a lot of it is based on ACS. The federal government also uses ACS to allocate funding. So for a lot of the programs that you see, the US code will say, okay, take data from the American Community Survey or whatever survey and, you know, plan funding allocation based on this particular variable. So it's also used for that kind of purpose. And the responses for this are required. So when you got your notice in the mail this year about the decennial census, they probably said, you know, it's your legal duty to fill this out. This is important for the sample because that, you know, it's a lot of pressure, right, to respond and you get a better sample. This is a nationally representative survey. So it's important to ensure that you have a high or a good proportion of people answering. Unlike the decennial, right, which happens every 10 years, so we have the 2000, 2010, and now the 2020 decennial census, ACS is a continuous survey. It's ongoing. Like I said, it's a nationally representative household survey. So they sample 250,000 addresses every month. And then there are basically accumulations of monthly data across 1, 3, which was phased out in 5-year periods. I'll discuss that later on. And using different kinds of estimates then gives you different abilities when you're working with different levels of geography. As far as coverage goes, so like I mentioned a couple times now, this is a household survey. You'll see that some of the variables are calculated at the household level, or most of them. Some of them are family and some of them are population in general. But in principle, it's the householder who responds. In 2006, they also added what we call group quarters. So this is places like college dorms, armed force barracks, you have it on the screen, prisons, nursing homes. So if you're interested in a special population like college students, you would be looking at variables that pertain to group quarters populations versus households, which is what the typical universe, what we call universe would be. What constitutes a household is a decades-long debate in the social sciences, and we're still not exactly sure on what that is, but for all intents and purposes, it's basically a spatial unit in a property that is occupied and is not, it has separate living quarters. So this can mean various different things, and depending on your conceptual framework, on your question, you might want to think about which variables you're pulling at the household level versus at the family level, what respondent type they were calculated for, and then always keep in the back of your mind that we don't exactly know what a household is, right? We just kind of take it as a unit because that's kind of how sampling goes here. You start with a master address list of all the housing units basically in the US, you sample from those and then you interview the householder. That's kind of how ACS is conducted. One important note on who responds to this survey is also that it basically captures people who are living or staying at that household address for more than 2 months out of the year. So if you have, a soldier that's been deployed for a very long time, that person might not get captured. So maybe you shouldn't be looking at that population. In general, you would be focusing on the group quarters populations and just look at people who are in army barracks, things like that. So you also have to be mindful here of people who move a lot, for example, so those will not be captured. And of course, you can't get, the homeless population will not be here because if there is no physical address, then that does not get captured here. In terms of time reference periods, you'll see this noted with the question. So it will usually say, and I think I have another slide for that, or maybe I don't, but just so you know, it'll say, we were asking you about this particular thing that happened in the past 12 months or in the past month. So that might matter for employment variables or for mobility variables. So they'll say, have you lived in this house for the past 12 months? Or have you been employed in the past month? In terms of, so another note on the content. So there's about 48 questions per person right now, and you can read more about how exactly it's structured or how follow-up works if you don't respond. There's a couple of links here, and I'll share these materials with you afterwards as well. Here's a slightly more detailed listing of all the variables that you can get here. So it's like I said, a fairly broad capture of sociodemographic and socioeconomic characteristics that are either at person, so household level. So those are mostly the variable groupings that you see on the left-hand side, and then on the right-hand side, we also have some property characteristics. So if you're interested in the housing stock and what it looks like, you can get some preliminary information on that from ACS as well. Here's the note. So I do have a time. So for each variable that you're looking at, you'll see what time period they're referring to. We already talked about the sample size. So they sent out a survey to those 250,000 housing units that they sampled from the master address file. This covers all the counties in the US, and there's a rule that basically they cycle through every 5 years, and that's how you get a nationally representative picture of the US. In total, that's about 3.5 million addresses every year. There's a note on the long form for 2000, which is a little bit outdated now. So when you look at the 5-year, and I already mentioned this, there's 1, 3, and 5-year estimates that allow you to get to different levels of geography in the ACS. You get to about 15 million housing units. Some of these are oversampled to ensure representativeness. So if you are working with a small county, place, township, school district, whatever geography there is, you might have to oversample that to ensure that you get enough responses to represent that unit. I'll get into the geographic terms a little bit actually in a second. So we'll talk about this. And here's also a link that you can follow up on afterwards to learn more about this. So for those of you who haven't worked with spatial data before or haven't worked with census geographies in particular, there's a standard hierarchy basically of how the census breaks down different geographies, and you can get estimates or, you know, pull variables at all these different various types of geographies. This is an approximate breakdown, and there's, you know, very specific definitions associated with each one of these divisions that I'm showing you here. So some of these terms will be familiar, right? So you can get estimates at the nation level. So for all of the US, let's say I'm interested in percent female, right? I can calculate percent female at the level of the US. Then I can go down into regions, divisions, you know, I can calculate percent female by state. Some subcomponents of states that are, well, approximately the same level would be school district or congressional district. Under states, you have counties, so that's like a fairly common sense term. You know what a county is. Counties can have voting districts or traffic analysis zones within them. There's also county subdivisions. And then a lot of the time when you're pulling data from the ACS, this is kind of like the realm that you'll be working with. It will either be county level, or let's say you have a project that's interested in just Fairfax County, Virginia. Well, then it will be more informative to break that down into even smaller units. So you might go to census tracts. So here's where we get into definitions that are based on the number of people. So census tracts, for example, are groupings of between 2,000 and 7,000 individuals. So you might think about that spatially, right? If you're looking at an urban county where the population density is high, those census tracts would be very small. So for example, Fairfax County in Virginia that I just mentioned, it's a pretty urban county, so there's about 140 tracts in there. But if you look at a rural county where the population density is small, you'll have very few census tracts. So for example, Patrick County in Virginia only has 4 census tracts. The grouping that's even smaller than census tracts, so now you can imagine, you know, you take a county, you break it down into 100 tracts, and then within each tract, there are even more block groups. And again, these are based on the number of people that live in a certain area. And then even smaller than that are census blocks, and that's the smallest area you can possibly get to. On the right hand side of this diagram, you also see American Indian, Alaska Native, and Native Hawaiian areas. That has a fairly different set of geographies. You will have to look that up if you're interested in that. I gave you a link down here where you can read the definitions of all of these different breakdowns and also find more information about alternative geographies for other areas. But basically, from this diagram, if there's one thing that you remember, it's that you can pull data from ACS or Census at all these different census geography units. The same holds for other federal data sets. So if you're looking at data from the Department of Labor Statistics, or labor statistics, if you're looking at Homeland Security, Centers for Disease Control, even, a lot of it will be on the same standard set of geographies. If you have something like an Department of Education, will have more data available at geographies that are more relevant to them. So like school districts, right, versus something like the Department of Labor will have maybe census tracts in counties. School districts are not relevant to them. Okay, so I have a couple of definitions here just so you can see. Some of these divisions are legal and some of them are statistical, right? So statistical definitions would be things like census tracts, which are based on the number of people, and some of them are legal, like a county or a voting I guess some of the voting geographies are like that. And again, I won't spend too much time on this, just so you know, there's legal definitions, there's statistical definitions. The statistical ones, a lot of the time, are either number, density, things like that, but you can read more about this in the geography reference manual that I've linked here. Another geography that you haven't seen yet, but I do want to mention, is in the public use microdata area. So these are geographies that you might want to consider if you're working with a rural area, because it might be easier to get estimates from it. And this might not be the most important point right now, but for those that are looking at or have projects that involve rural data, you might be, this is something that you might want to consider. So as I mentioned before, you can get, so ACS data gets pulled at these different time intervals. There's 1-year estimates, 3-year estimates, and 5-year estimates. 1-year estimates will give you the best recency, right? So this is the most recent data, but it won't go down to a very low geographic level, right? So when I was showing you that diagram that went down to the blocks before, you won't be able to get 1-year estimates lower than mostly the county level, because the data is only provided for areas with populations that have more than 65,000 residents. The 3-year estimates I won't spend time on because they have been phased out a couple years ago, so they're no longer available. But then there's also the 5-year estimates, which you can imagine, right, are not the most recent, because they basically pull data from the past 5 years. So the most recent estimates out right now are the 2014 to 2018 estimates. You can kind of think of it as, 2016 as the midpoint, although that is not technically correct. But it will give you the best geographic precision. So if you need data at the census block level, this is more or less your only choice. Census gives you this really nice table breakdown with more details on when to use which particular set of estimates. But just so you know, right, if you're looking for a very granular, very spatially granular information, you would be looking at 5-year estimates, versus if you're more interested in data that is very recent and you don't necessarily need to work at a level that is lower than county, then you would go for the most recent 1-year estimates. And again, I'm linking to more information down here. Once you start looking at the types of tables, and we'll talk about this a little bit more. So ACS and Census provide data in table form. It's not quite the way you would imagine a data set to come to you typically. There are several different data types or products that ACS rolls out. Some of the tables are detailed tables. This is what you would ideally be looking for. There's subject tables, ranking ones, selected population profiles. This will make more sense when you start working with the data, but just so you're aware that there's various different types of tables there. Some of them are special populations. Some of them will give you really detailed breakdowns. Some of them will pull some of the information for you, so you don't have to do as many calculations. Again, you can read more about this on the website, but just so you know, once we start looking at tables, depending on the level of geography that you're working in and the information that you're interested in, you would be looking, or you would want to search for different profiles or different tables. Each one of these will have basically a standard structure, so you can know what type of table you're looking at, even if you just search for it online and you see this code, you can kind of read the code. For us, this is more important because once you start working with the Tidy Census or the Census API in general, you will need this code to pull the information. So typically, the first digit or letter here will be the data product type. So B are detailed tables, C are collapsed detailed tables. Then you'll have the table subject. So that's that basically screenshot that I showed you before. That was a breakdown of all the subjects that are captured in ACS. Each one of them has a number. Then there's a unique table identifier, which is the number basically on of the table in that series. And if there are detailed breakdowns of the table by race, you'll have a designation for that as well. And for Puerto Rico geography, if it's not a US general table, if it's just available for Puerto Rico. Again, there are many of these table codes and I'm linking them here, but you'll see this once we start looking at the API. Another important thing to know about ACS is that you're not only going to be retrieving or getting the estimates or values of a variable, you'll also get a margin of error. So because this is a sample survey, it's not a complete enumeration of the US population, there's always some error associated with the estimates that you're getting. And by default, ACS will report a 90% confidence interval around the estimate. So if, for some geography, we say, okay, there's 55,000 females living in this particular tract, and then you'll get a margin of error that says, but that's plus minus 700, right? Depending on how well that estimate was measured. So whenever you make a call to the API, you'll get both the estimate and the 90% margin of error. You can also request other margins of error. You can do the 95, you can do something completely custom like 16% or whatever, but just so you know that there's going to be an additional number that's going to come in, and that is the margin of error. I think I have another slide here, but basically, from your stats 101, you remember how we get to calculating this and what it means. Okay. So this was kind of like a quick tour of what we can expect from the Decennial and ACS, but most of you actually have a very practical problem right now, which is how do I actually get this data and wrangle it? So I'm going to show you that as well. I have some slides here that I made just so that once I share them with you, you can have them and reference them back, but we can also just, I think I have this, set up here online and we can look at it. But basically, the easiest way, if you're completely new to working with and maybe I'll just show you this on the website and share the slides with you. If you're completely new to working with Census and ACS data, the easiest thing for you to see what's actually in the back of what you're pulling through the API is to go to data.census.gov, which is going to throw you this nice little one-line search bar. And let's say that we're interested in, I don't know, educational attainment in the US or something. So I'm just gonna leave it here, not gonna select anything that's suggesting me and say search. Then I get a bunch of these things out here, and typically I'll be interested in tables. I'm gonna skip what it's showing me here, and I just want to view all the tables that are associated with educational attainment. And I get this portal here that is very confusing because it has a lot of information. So, and we're going to walk through all of these things, but the first thing you want to do is filter the you have the search results here. The first thing you want to do is filter this based on what you need, right? So we talked about geography. Maybe you need something that's very geographically granular. Maybe you don't care. Maybe you care about which particular year, maybe you don't. For the purposes of this demonstration, I'm just going to say, okay, I need something that's, say, at the tract level. So I already know that I need to go to the 5-year estimates. And because I know that I'm looking for some really detailed information about education, I'm going to go to the 5-year detailed estimates tables. So only show me the search results that are in the 5-year estimates detailed tables. I'm going to filter it to this. It's still giving me a bunch of different tables. And then one thing to know about ACS is that a lot of the time, it's not going to give you just a breakdown of gender, just a breakdown of education, just a breakdown of % people living in poverty. It's going to give you crosstabs of 2 or 3 variables. That has a bunch of different purposes. One of them is, a concern for re-identification. So they're giving you like across categories, right? So for example, this one is geographical mobility in the past year by educational attainment. So what you typically want is a breakdown of a variable at the least complicated level there is. But again, this depends on your conceptual framework and on your question. But what you want to do in most cases is find just a variable about educational attainment and not cross-tabbed with anything else, so you don't have to perform your own calculations and possibly introduce errors into what you're doing. So I'm going to keep scrolling here a little bit and see if I can just get a variable, and here it is, educational attainment for the population 25 years and over not tabbed by anything else, right? So this one is sex by educational attainment. This one is already more complicated than what I actually want. So I'm gonna click to look at what this table looks like. Okay, perfect, right? This is exactly what I wanted. And if this variable didn't show up here, I would keep clicking load more to see if maybe I can find it somewhere else. But now that we're happy with this table, here's some information that you have to pay attention to that will be relevant for when we're pulling information in with the API. So here's my variable name, educational attainment for the population 25 years and older. And this second part already signifies something interesting that you should be mindful of every time you pull any variable. This is my universe, right? So this means that this particular variable was only collected and calculated for the population aged 25 years and over. In this case, this makes perfect sense, right? That is about the age at which we can say, okay, this person has completed schooling, they probably won't go and get 17 more degrees. So we can say this is kind of like an approximation of the terminal education that the population has. For most of the variables, this would say household, or if it's relevant to family structure, it would say family. That's what I was mentioning before, right? So you have to pay attention to what the universe is. Some of this would be calculated for population age 1 and above. There's some special universes, like poverty variables will be calculated for populations for which poverty level is determined, which is quite a nebulous description, and then you have to go to a code book and user manuals and figure out what that means. But basically, I can't really give you general guidelines here. Depending on your research question, depending on the population that you're interested in, you will always want this universe to align with the population that you're actually exploring. So let's say that I'm interested in adults in general, so this is perfect for me. Okay, what am I looking at here? First, we have this estimate column, right? And we have rows. Every row has an estimate. Because this is population age 25 years and over, these are counts of population 25 years and over that fall into each one of these categories. So in the US in general, because this table is at the most general level showing me numbers for the United States, in the latest 5-year estimates, approximately, let's say, 42 million people, their highest degree was a bachelor's degree. And then I have my margin of error here, which, as we discussed before, by default, this is a 90% margin of error, plus minus 154,000. So these are the numbers that would come in when I do my API pull. Another thing to pay attention to, here's your table ID, right? We talked about these designations before. B means that this is a detailed table. Then I have the topic here, which is 15, which is educational attainment. And then the table ID number is 003. What I'm gonna need when I do my API pool is this whole number. And then one trick to know is that when this information comes in, or if you want particular rows from this table, the way that these are numbered is gonna be, so this row is the first row, right? So this would be B15003 underscore 001. This one will be B15003 underscore 002 and so on, right? And let's say that this is the 20th row. So this would be underscore 020. Okay, so that's how we know which row corresponds to which category here. So that's why it's also useful to always kind of like have this data.census.gov open, especially when you're just starting out, so that you know what your data actually corresponds to. If you're looking at the decennial census, this would be fairly similar. This would say decennial census, your universe would be total population. It's really, really similar. There will be tables that will have table designations. So for anything that I'm talking about that pertains to ACS, there's an analogous thing going on for census for those of you that are working with the decennial census. So just to recap, always pay attention to the table number. You'll always need the table ID. Always be mindful of your universe, and the information that you're getting corresponds to these rows, and then you get an estimate and you get a margin of error. And then let's see. So once you start actually working with Tidy Census, the package, and I'll write that down under resources that I email or post afterwards so that you know which packages to actually look at. I think I'll pull up my slides here. Sorry. This is what this looks like. Okay, this is what I was showing you before. So here's the information that you're going to need. And I would encourage you to annotate your code heavily, especially when you're starting out, just so you know what you're pulling. Right here, you can see some of my tables, my table numbers. This is what I would put, in comments for myself. Okay, I'm going to pull information about the population age 65 plus, so my older adults, my youth and teens and children, percent population Hispanic or Latino. And for example, to calculate the percent population that's Hispanic, I'm going to need these two particular variables. So this is a Hispanic ethnicity table that has 3 rows. One is total population, one is not Hispanic, and one is Hispanic. So to get the percent population Hispanic, I'm going to need to divide the number of people who are Hispanic, and that is row 3. So I'm looking at this table, the 3rd row. I'm going to need to divide it by the 1st row, which is my denominator, which is total population. So that will be the table number. Sorry, there's an error in this one. For total population, this should say 3,001, because that's the first one. And then to get the percent, I'm going to multiply it by 100, but that's the idea, right? So I'm writing down to myself, or this is the one that we were looking at before, to calculate the percent population over the age of 55 that doesn't have a bachelor's degree. I'm going to have to sum all the rows from 2 to 21 and then divide that by the total population and multiply by 100. And I'm going to get the percent population that's over the age of 25 but doesn't have a bachelor's degree. And then I do the same thing for all these other variables that I'm interested in. Then if you're working with tidy census, one thing to not clog up your API call would be to pull or assemble your variables into a separate vector that I'm calling here ACS variables. And I'm just saying, okay, for age 65 plus, here's all the variables that I'm going to need. For Hispanic, here's the variables that I'm going to need. For Black, blah, blah, blah. I outline them all. I annotate this so that when I go back to my code 3 months from now, I know exactly what this refers to. I put it all into a vector, and then I make my API call. So before you can use tidy census, you're going to have to register for a census API key. If you just Google, create census API key, it's a form with 2 fields. You submit your email and you get your key, and that's it. But just so you know, because I think there's a slide that I should have included on that I don't have here, but I'll put it in the notes. And then I'll say, okay, this is what the typical call looks like. You'll see this in the tidy census documentation as well, but it has a lot of the fields that we were talking about before. So when I say get ACS, or if you're working with the decennial census, you're gonna say get decennial. You'll say, here's the geography that I need. And in my case, I'm pulling this information for census tract. If you're interested in a particular state in a particular county, you can specify that information. If you want information for all the states or all the counties, you might have to write a loop. So you'll see in some calls, you can include multiple states, or you have to kind of loop through the FIPS codes for states, which is what this code is. It also takes text or strings here, so I could say state equals Virginia and it would know. But here I'm just saying, because I know that the FIPS for Virginia is 51, I'm saying 51. The same thing for county. I could say Patrick County here instead of 141 and it would still work. Then I'm going to say for this particular geography in this state and in this county, pull these variables that we specified up here. So I want all these variables, and you can see now what I was saying about not clogging up the API call. If I tried to squeeze all of this into my API call, this code would look really ugly. Then I'm going to say I want the most recent estimates, which for right now are 2018. And the survey that I want is ACS 5, which means ACS 5-year estimates. If I wanted 3-year estimates or 1-year estimates, this would change. If you do $get ACS, as you know, you'll get more information for all the fields that you can put in here and what the accepted values are. If you're working with the decennial census, your survey will be either SF3 or SF1, which stands for short form or long form. Then I'm adding a bunch of additional things here that will help me later on, might not be as relevant right now, but basically I'm storing some of this information so that my future calls are quicker. I'm requesting a wide output because that will make it easier for me to manipulate the data afterwards. And I'm also requesting the geometries. So this is an interesting set of options that you can add if you plan on plotting your data, which I assume most of you are. So what this does under the hood is it uses the Tigris package, which is another package designed to interact with the Census Geographies API to get the shape files or the geometries for you. So you don't have to go do a separate call that says, okay, give me the borders of all these counties and states so that I can draw a map, right? So if you already know that you're going to be making plots and maps, include geometry equals true and keep the geographic identifier variables. That will help you to also link data sets across, census products or across the federal statistical system products. Because as long as there's the same geographic identifiers, and there typically are, they're called GeoIDs, you'll see them in the data, you can link between geographies. And maybe if we have time, I'll show you that as well. But basically, this would be your standard minimum set of things that you would want to include in your API call. And this will retrieve this information that we were looking at in my other window here, right? Except in my case, it will get it for Patrick County, Virginia, not for the United States. This is just so I can see what the data looks like. If I could find my slides again, okay. Here's a case where you have to loop through something, right? So if you want to do a call, for example, here I'm doing the same thing, but I'm getting data for a county. I'm gonna have to loop through the states so that I don't have to do 3 separate copy pastes of the same code, right? One for Iowa, one for Virginia, one for Oregon. I'm just gonna write this loop, go through it 3 times. R will put a different FIPS code here every time, and then basically append the data so that I have a data set for all these 3 different states of all their counties, all these variables, again, with their geometries. So this is another thing that you might have to do if you're pulling information for multiple states or multiple counties or multiple what have you. And then when you get your data, it's gonna look like the estimates and margins that I told you about. So there's gonna be a bunch of geographic identifiers, which are these ones up here. And then you're gonna wanna calculate your variables. So again, this is where annotations will be very helpful, right? You don't wanna be making up these numbers off the top of your head. You wanna go back and reference, okay, so, once you've worked with this for a couple of years, you will know that this is the age table, but until you get to that point, you might wanna tell yourself repeatedly with things like this, okay, this is the age variable, and this is the male category and things like that, so that you know what you're calculating. But for a very basic application, this is kind of how you would calculate like proportions or percentages. I'm saying transmute, which will drop all the other variables in the data frame and just keep what I'm actually calculating. And I'll say, to calculate the percent of people in a census tract that are age 65 and over, I need to sum the number of people over age 65 that are male and the number of females age 65 and over, and then divide that by the total population and multiply it by 100. And then I'll do the same thing for my children. I'll do the same thing to do the Hispanic population, right? So the number of people who are Hispanic divided by the total population and multiply by 100 to get a percentage. And then I'll do it for my other variables, and then I'll conclude my call. And that's how you would get a basic data frame with your estimates. You'll see this suffix here. That's because when I remember when I told you make the API call, you get estimates and margins of error. So this is the table number, this is the row number. This means that it's the estimate. If I was interested in the margin of error, that variable will have the suffix M. So you could also work with that, right? If you wanted to include the margin of error for here, you would do a separate calculation. Just a brief note on the geographic identifiers, and then we'll see if we have questions. A lot of what you get here is, as I mentioned, what you would get in a different federal or any data set really that uses census geographies as well. So state FP will be the state FIPS code. Oh, that was the 51 over there for Virginia that I was showing you. So these are standard codes for states and counties. Sorry. There will be the same thing for county FIPS, which was 141 over there for Patrick County in the example that I was showing you. Then you'll have this identifier for tract along the same levels. And then one important thing to pay attention to is the GeoID. So the GeoID is the geographic identifier, which if you pull a census data set for the decennial census and one from ACS and one from loads and one from another federal data set, and they all have geographies, you'll be able to link them on GeoID. So GeoIDs are these standard identifiers where the first 2 digits are the state FIPS code, the second 3 digits are the county FIPS, and then you have a couple digits for tract, for block group, for block, right? If that's the geography kind of in the hierarchy that we were looking at before that you're looking at, that will be a very typical sequence. You can always parse it. So if you get a data set that only has GeoIDs in there and you're like, I have no idea what state or county or tract this is representing, just know that the first 2 digits are state, the second 3 digits are county, and you can parse that string and you'll know exactly what state and county you're looking at. Or in another application, right, as I said, if you have GeoIDs across multiple different data sets, you can join on GeoIDs. If you Google this, you'll see what it looks like, what it means if you have a different set of geographies, but this is a really, really useful variable that you should always pay attention to. Another note here is that Alabama has a FIPS code of 01. So sometimes if you're reading in a data set that has a GeoID and you accidentally read this in as number rather than string, it will drop the leading 0. So you'll have a GeoID that has an inconsistent number of digits and that will mess up your merge. It's because you dropped the leading 0. So that's like a super common error. You know, students will say, okay, but you told us that this works, but it doesn't work. Well, it's because you dropped the leading 0. So even if it doesn't make a lot of sense right now, if any of you are looking at Alabama or another state that has a 0 in the FIPS code, make note of this and be very careful with your GeoIDs. Names will typically be short and long names. That it's a descriptive thing, you know, keep it because it will tell you, you know, name Y or whatever will say, this is Patrick County, Virginia. It should be a Y here. I was writing this yesterday, so it's kind of messy. And then land and water are useful to keep if you are calculating population density or anything like that, because this is giving you the land area in square meters and the water area also in square meters. So if you want that in square feet or whatever, you're gonna have to do some transformations. Just know that these might be useful for you. And yeah, they're in square meters. And the geometry here, lastly, is that geometry column. You'll see it's a nested list column, but you can use it with the base R plot capabilities. If you do, you know, plot, you just wrap it in geometry, it'll plot the geometry because it knows to go to this column. Or if you're using the SF package or the SP package, you might have to do some data wrangling, but you can plot it either with base R or with ggplot or with leaflet or what have you, right? So this is the column that you would be working with once you start doing spatial operations, or if you just want a really simple map of what you just calculated. But this is basically, yeah, the quick, very whirlwind tour introduction to decennial and ACS data and how to work with it. It's to get you started and give you kind of the you know, framework for working with it so that you know the keywords once you start Googling. I say this a lot. We are professional Googlers at this point, right? And a lot of how you're gonna learn is, oh, Teja said something about GeoIDs, and then you're gonna have to go and Google GeoIDs and learn what you actually need to know for the purposes of your project. So I'll post all these materials somewhere so that you can reference it afterwards, and you can always send me an email, and we have a bunch of other people in the lab that work with ACS. Josh would be a good person to ask. Devika works with ACS. Aaron probably knows everything there is to know about spatial data. So there's a lot of resources. There's a lot of excellent tutorials out there. I'll post some of the links as well. But I guess, let's see, there's something else here. I don't see anything in the chat, but if you have any questions, I would be happy to answer.
I have a question.
Sure.
Can you go over how to upload your Census API key? I know you glanced over that before, but like once you actually have a key.
Yeah, sure. So there's several different ways to do this. I'm just pulling up my some code so that you can see. There's two ways once you have it. One is to spell it out every time. And the other one is to store it as an environment variable, which might be the safer way to do it. So you're not exposing the key for everyone to see. There we go. Okay. I'm going to share my screen. Okay, so now you're all going to see my key, right? So this is what you would do at the beginning of the session if you weren't contributing data to a public-facing open Git repo so that everyone can see your, I mean, an API key for a census isn't the most sensitive piece of information out there, but you know, it's just good practice to get into not doing things this way. But say you only need this for one session and you're not going to save it anywhere public facing, you would just say census API key, paste it in, and then, you know, do all the stuff that we were talking about doing, and it's going to work. You could also paste your key in here when you do the get ACS command. There's an option here where you can say key equals and put it in here. The Census API key command also has an option here that says install equals true, and that would install your key for future sessions, so you didn't have to keep pasting it in. But the best way to do it is to store it as an environment variable. So what you would do is when you are in your RStudio or in R and you're looking at your directory structure, there is a .renviron file, and you can put your census key in there, say census API key equals, and then your key, save that file, and then have R read your environment and get the key from there. So that in that way, right, when I push this code to GitHub or whatever, it's retrieving it from the environment, and the people looking at that piece of code don't actually see your key. They just see that you're pulling it in from the environment. I don't have a session open right now to show this to you, but you can also, if you want more step-by-step instructions for how to do this, you can just Google, you know, save API key as our environment variable, and I'm sure you're going to get 10 excellent tutorials on how to do that. It's really simple. You basically identify a variable, paste your API key in, and then use these 2 lines of codes and you're set.
Thank you.